So hello everyone, welcome again, and today we are going to solve a new question. And this question is from our binary tree, and this is the first question from this series. And from today we are going to start the series of binary tree. And the first question, what we have to do is that you have to find the level of a binary tree. That is the maximum depth of the binary tree. So in the traversal which you have done in the binary tree, you have understood level of the traversal. So if you are able to get how many levels are present in that binary tree, it will be its maximum depth. Now, this question is also be solved using recursion, which we are going to solve in this question, and you can try the level order by using level order traversal in your own. Now, let's understand it with example. So here I have taken the example one from the question, which consists of the nodes 3, 9, 20, 15, and 7. And we have to find the maximum depth of this binary tree. So what is the maximum depth? So it is the maximum levels it is making. So by using level or traversal, you can simply find how many levels it has and you can return that. So you can try that on your own. Now here what we are going to discuss is that the simple approach, which is recursive approach. Now by recursion, how you can find this? So in recursive approach, what you can think is that let's assume you are starting or you are standing at root node. So if you are standing at the root node, what you are seeing that there are two branches coming out of this node. First is on the left part, second is on the right part. They have their own maximum height. That means this node has its own maximum height, and this root tree has its own maximum height. So whichever part have the maximum is going to sum up to the root node, because we have to find the maximum depth. So using this insight, what you can do, you can simply write a recursive function, and what it is this, that you can write the maximum height of the binary tree, which is, let's assume that f node, this is going to be a root node, is equals to 1 plus, that means the its own height, 1 plus max of maximum height which you achieve from the left part, and the maximum height which you get from the right part, that means f and right. So this is the recursive function which is going to solve this, you applied in this question. Now how it is going to work, let's understand. So in the starting, what you have three, and there you have going to call two functions. First is going to call for the 9. So here we have called two functions, first for the 9 and second for the 20. So these two have their own function call. Now what will happen when you are at the 9 there, let's take the first function call which is coming at the root 9. What will happen, it again call for the left and for the right. Now when it's called for the left, what will happen, that there is no node. So if you find that there is no node, what you can do is that you can simply return 0, because if there is no node, that means the height is 0. So what it is returning, it is returning 0. The right part is returning also 0, because it also have null. Now when they return 0 0, what will happen when you apply use this function, that means when their function call at the 9, what will happen, that this function's left part is giving 0 and this right part is giving 0. So maximum is 0 and its own height, that is 1. So what it will return, it will return 1. Okay, now let's come to the right part. So first call to 20, second call to 15, and third call to 7. Now let's analyze these two. So there is again left and right call which is going to return 0 0, and by using this max, what you get max 0, and adding 1, this 15 is again going to return 1 similar to the 9, and this 7 will also going to return 1 similar to both 9 and 15. Now when you are at 20, then function max left and right has returned 1 1. So maximum is going to be 1 and 1 for its own height for 20. So this is going to return 2. So here you can see that the left branch for this root node 3 is returning 1 and the right branch is returning true 2. So the maximum of 1 and 2 is going to be 2 and its own height is 1. So it is going to give us final maximum height is going to be 3. So here we have found the corrected maximum height of a binary tree. So that's how the recursive function is going to work. Now let's code it. So let's start. So what we have discussed is that when we are at a position where we are getting root as equals to null, so what we have to check is that if our root is not valid, that means it is null. So what we have to do, we have to simply return 0. So this is our stopping condition for the recursion. Now what we have to do is that we have to simply return. So what we are returning, we are returning 1 plus max of max of max depth root left, comma max depth root right. So what we have done, as we have discussed, that we have written the formula, that means the recursive function for this code, which is going to return the maximum depth for this root node. Now let's run this code. So this is accepted. Now let's submit this. So this is a very easy question, and this is the first question. In this question, you have understood the importance of recursive function, how it has makes the question very simpler. Now, what we are going to do is that you have to solve this question using the level order traversal. You can analyze how you can solve that, and you can comment in the comment section how you have solved it. Now you are going to see the solution for both Java and Python. So stay tuned, and let's meet in the next video, and let's solve a very interesting question in the next video of the link list. Thank you.